Howdy calculates. So I've done a lot of writing on this already. You probably want to pause the video and get stuff down. Hopefully you tried to set this up yourself. And the only major addition that you probably really needed was 7 feet from the wall. That was a little awkward and that I didn't finish that question. So pause the video, see if everything makes sense that I have on here before you proceed. And then, of course, you just got to plug and chug, just like we've been doing in class. This question was not really a new question, which is why I went ahead and set it all up. So hopefully you were able to get to the final answer all by yourself. Again, we'd done problems like this in class, so I rushed ahead and didn't do a whole lot of explanation. I kind of feel like you had it from class, so move on to the next one. See if you can set that one up before you peek, and then we'll see if you get your correct answer. So again, I added this little piece over here about being 15 feet from the wall, and I'll solve for y using Pythagorean theorem. And now I've got to put all my rates in from the stem of the problem, which was up above. So I still have the same change in the move away from the wall for the base of the ladder. Still looking for how fast it's moving down the wall. Of course, the ladder isn't changing in length. And here is my derivative that I've been using. So I'm ready to plug and chug. So hopefully when you plugged and chugged, you got this final answer. Okay, see if you can set up part C. Okay, so now paying attention to what it's asking you for, the rate at which the area is changing. So now I need to be using area formula, and based on how I've labeled my triangle, it would be 1/2 x times y, because that would be base times height. So the derivative would be dA dt equals, remember that 1/2 is going to hang out in front. Well, xy does their thing, and they gots to do the product rule. So first times derivative of second plus second times derivative of first. And then hopefully I have enough information to plug and chug. So now you might be wondering how much is dy dt, but this is the problem we started with in letter A. Same exact sides, which means my dy dt is -7/12 from answer A, so I'm going to plug that in. And then the rest of it I have labeled right here in this triangle. And so now I just have to work it out. Hopefully I did all my math right and I have the right answer. I'm pretty sure I do though. I think I multiplied all those fractions correctly. And hopefully you get the same answer. Okay, moving on to letter D. Okay, so reminder, this is still the same problem from letter A. So I do know my dy dt, and I'm looking for the angle between the ladder and the wall of the house, so that's the one at the top. And I can use any trig function because I have everything in this triangle that I need. So I have a tendency to like tangent, but you can use another one that you like. So for my setup, opposite over adjacent would be x over y. And then when I take the derivative, I get secant squared. Again, you would be doing a different derivative for your trig function if you use sine or cosine. And of course I have to use the quotient rule. And then I'll sub in. So hopefully you got to 1/12. Remember, if we want to convert that into degrees, we have to multiply by 180 over pi, which would give us 4.77 degrees per second. So remember, if you're having trouble with these, I am available before school, at lunch, and in the library after school.